Hello everybody. In this video, we are going to continue solving another problem live from LeetCode's top interview 150 problem list. So far, we have solved all the problems up to valid palindrome. If you haven't checked out my videos on those problems, please go to my channel and check them out. Uh, the next one is subsequence. So let's read the problem and make sure we understand it. Given two strings s and t, return true if S is a subsequence of T, false otherwise. Okay, a subsequence of a string is a new string that is formed from the original string by deleting some can be none of the characters without disturbing the relative positions of the remaining characters. Okay, uh, yeah, that's actually a standard definition of a subsequence versus a substring. Substring is, characters which are adjoining to each other, adjacent to each other, while subsequence can be formed of characters which are not next to each other, but they have to appear in the same relative order in the original string as the subsequence. So yeah, but they have given a slightly more accurate definition of how a subsequence works. Okay, so for example, here they say ACE is a subsequence of ABCDE, and that's because they have underlined the characters they have kept, and the non-underlined characters can be deleted, and that will give us ACE, like removing B and D. While ACC is not, yeah, there's nothing you can delete here. No subset of characters can be deleted from the original string here to form AXC. Okay, so let's see. The two examples are S is ABC and T is AHBGDC. Yeah, in this case, we can get ABC by removing HGD, and that's why it should return true. While AXC, yeah, that cannot be formed from this T, so we return false. Okay, makes sense. The constraints are that the length of S is between 0 and 100 inclusive, the length of T is between 0 and 10,000 inclusive, and S and T consist only of lowercase English letters. Okay, so they have also a follow-up. Let's read that. Suppose there are lots of incoming S, say S1, S2, dot, 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 Sk, where K is bigger or equal to 1 billion, okay? And you want to check one by one to see if T has that subsequence. In this scenario, how would you change your code? Oh, that's interesting. I think what they're asking is if T remains the same, but we get lots and lots of different S's to be checked for whether they are subsequences or not, then how would our approach change? Yeah, okay. Anyway, we'll keep that in mind and think about it once we solve the main problem. So let's look at the main problem first. Well, I mean, the approach here is pretty straightforward, right? Like we can keep two pointers, one in S, one in T. So let's take an example, ABC, AH, BG, DC, right? So let's say we say S index starts at 0 and T index also starts at 0, right? And what we do is we compare the characters at that or at those indices in those two strings. If they are the same, then we increment both the pointers. If they are not the same, then we only increment T pointer, right, or T index. So in this case, at 0, they both are A, so we are going to increment both. So this becomes 1, this also becomes 1. Now at 1, they do not match. So we do not increment S index because we haven't seen that character. We have to find that character in T, right, after index 1. So in T, though, we are going to increment it because we know the character at 1 does not match. Now the character at 1 in S and 2 in T does match. So then what we do is we say, yes, we will increment T and S both. Sorry, this will become 2, right? And then finally, actually not finally yet, but anyway, at 2 and 3 does not match. So we keep skipping. Again, at 2 and 4, it also doesn't match. So we keep skipping. And then finally at 2 and 5, they match. So we increment both, right? In this case, we ran out of characters from both at the same time, but that doesn't have to be true. But the point is, if we have, consumed all the characters in S, then S is a subsequence, right? So that's the simple approach, and we are going to try to implement that. One second, let me just make a bit more room here. Okay, I'm going to make this a bit bigger as well. Okay, so the approach is pretty simple. We say s index equal to 0, and since our t index increments every time, we can just write it in the for loop. Equal to 0, t index is less than t dot length plus t index, right? Okay, and now we say, well, first we say that if s index has reached s dot length, right? Uh, then we return true because that means we have finished all matching all the characters of s. This can be greater or equal to, but if we don't have bugs in our code, it shouldn't really need greater or equal to. But you could easily switch equal with greater equal to, and that will also be fine. Otherwise, we match the characters, right? We say if s dot char at s index is equal t dot char at t index, then we increment s index. And t index is always incremented, but that's already done as part of the for loop here. And so we don't have to do anything there. And here we still say return uh, s index equal s dot length, right? If because in the if the last character matched, we wouldn't run the next iteration of the for loop. So we still need to do, we cannot return false outside. We still need to check whether we have finished matching all the characters in S. Okay, so I think that should be all. Let's try to run the code and see what happens. It's pretty simple, so I'm not really manually running it like I usually do. Okay, great. So it got accepted. We could add a bunch of test cases here, like, like I always say, in arrays off by one errors, add test cases for those and stuff like that. But for the sake of, the video short, keeping the video short, I'm going to not do that and just kind of submit and see how we do against a lot more test cases and also how our performance is. Okay, so it did get accepted. Well, I'm very surprised that we only beat 61% of folks in time. And memory, yeah, like I say, in such problems, memory percentage is not significant when we use O of 1 memory because most submissions do use O of 1 memory. I mean, I wonder what we have done that is a little bit. Our algorithm is obviously O of n, where actually, let's talk about that a little bit, right? I don't see a complexity problem here compared to other submissions, but there could be some practical optimizations we can do. So if let's say let um, n be length of t and k be length of s, right? In that case, our algorithm is O of n. And the reason is because in the worst case, we may have to look at all the characters in t, which may be a much longer string than s, but that is how our algorithm is implemented. And the worst case would be, I guess, when s is not a subsequence of t, right? So if yeah, if it is not a subsequence, we have to go all the way to the end of it to figure it out. We could add some weird short circuits inside the for loop, like, oh, if the remaining characters in s are more than the remaining characters in t, then short circuit and return false. But I don't think that is going to be a good idea and will improve the overall performance of our submission compared to others, right? So I'm not yet going to try it and see if there are other things we can do. Let's see. And one thing we can do is that instead of we manually looking into every character in T and seeing where our next character in S is, we could just use the index of function that Java provides in the string class and call it on T, right? So I'm not sure why that would be faster because that would still be implemented with a loop, but it's always possible that right now we are doing caret, and when we do caret to get a character at a specific index in a string, it's possible that that is doing a couple of, you know, One second, I meant to take this code in a separate helper. A couple of extra if condition checks every time we access a character in T. While if you just call T dot index off, then that might actually be doing fewer checks, right? So I haven't looked at the implementations of those, and that's why I do not know for sure, but we can try it out very easily. And it's a slightly different approach, so maybe let's actually implement it, right? So is subsequence, I'm just going to call it one for a lack of better name for now. That is not we should what we should do usually, but okay. So let's paste this here so we save it and we don't lose our first implementation. Okay. So what I'm saying is the second implementation is going to something like this. Okay, is subsequence to string s string t. Okay. So the second implementation is that instead of looping over t in for loop and then trying to increment s only when it is the character matches, we are going to do the other way around. So we are going to int s index equal to 0, s index is less than s dot length, and plus plus s index, right? So we are going to do that. Let me make room again like I did last time. One second. Yeah. And here we say, okay, hey, we need to find the character. Let me actually take it in a variable just so that it's really clear, right? S dot char at I. This is the character, sorry, not I, S index, right? S index. This is the character we need to find. And where do we need to find it? In T, starting from T index or later, right? So we just use the index of function for that. So we say int position equals T dot index of, you give it the character ch, and you give it the T index that, hey, find me ch in T starting at position T index or later, right? That is the same as a for loop that we would have written or we wrote in the previous implementation. But my assumption that I'm trying is that T dot index of is much faster than our for loop inside which we were doing T dot char at, which might actually be doing multiple if condition checks for the bounds of the string, right? So, and then if we say if position equals minus 1, then we return false, right? We didn't even find that character of s in T, so we return. And otherwise we say T index equal to position plus 1, right? Because now the next character of s has to be found in the position where we found the character, the current character plus 1, right? And if all of that works, then we return true, right? We found every character in S by looping through it at some position, right? And uh, and so on. So yeah, so let's at least make sure the algorithm works before we submit for performance. Okay, so oh yeah, return statement is missing. One second, where is that missing? Oh, okay, okay, because I didn't call the helper yet. Okay, so I do need to call this here, of course. Return this s comma t, right? Okay, so now let's run it. Okay, so cool. So we did get accepted, and this time again, I'm going to use, oh, sorry about that. I'm going to submit and see how we do. Okay, there you go. So I think looks like the assumption was right, and that somehow t dot index of is much faster than we doing s dot caret and writing a loop to find the next character, right? So, and that's why we beat 100% of folks in time. Okay. Hopefully that was helpful. Actually, wait, so there was a follow-up, right? I forgot about that. Well, I think the follow-up is very interesting, and I think I would like to do a separate video on the follow-up because there are many approaches we could take here. Like we could just to give you a flavor of why that would be a bit of a longer video. Um, like we could just generate all subsequences of the given t and store them somewhere in a hash map or something and just you know quickly look up in O of one, presumably O of one, right? That a subsequence exists or not. But although it seems O of one, it's not. It's O of k, where k is the length of the subsequence, because in order to find hash code of a specific string, we have to traverse through each character of that string. So it's kind of interesting, and there might be some tree approaches or something we could take. So I'm going to just produce a different video on that. But for now, I think I'm going to end this video. If you're liking what I'm doing on this channel, please consider subscribing to my channel. It really helps me out. And hit that thumbs up button on this video. See you guys next time.